Well, let's give this a try. This is a gear demonstration for Principles of Engineering. And here's what I want you to do as a starter. Here we have two gears that are meshed together. And I have some things I want you to answer. First, right now, and you can pause the video if you need to, count how many teeth does each gear have. And I think you can see here that I'm going to make this gear A and this gear B. That's how we're going to distinguish them. And count how many teeth they have. Okay, do that right now. And record it in your notebook. Then here's what I'm going to do. I'm going to rotate these now. I'm going to spin these with my finger, and I'm going to try to keep them to a constant angular velocity. Okay, now am I going to be perfect? Probably not, but it's going to be really close. And so what I want you to do is I'm going to say go, and when I say go, I'm going to start spinning these. And I want you, and what I'm going to do is I'm going to spin this thing 4 times. And then from that, I want you to calculate what is the angular velocity of gear A and what is the angular velocity of gear B, and record it right here. Okay, on your mark, let's see, on your mark, get set, go. 1, 2, 3, 4. Okay, so angular velocity, determine what the angular velocity of this was and the angular velocity of this gear. And let's do it in radians per second, make it a little bit challenging. So I started here and I went 1, 2, 3, 4. Okay, so this rotated 4 rotations, so you should be able to figure out what the radians was, and then time, then time it, and it's just the number of radians divided by the time it took, and that'll get you angular velocity for this. But this one will be a little bit more challenging. So go ahead and do that, and pause the video and do that. Okay, now I want you to look at some ratios. I want you to calculate the ratio of the teeth of A to B. And then I want you to calculate the ratio of the angular velocity, but this time I want you to do B over A. And let's see if you notice anything about these ratios, and maybe you can figure out why. Then I want you to extend this idea to this. What is the same for both gears? Now, as these things turn, what quantity is the same? Okay, and this is really important. And so think about it, talk about it with the people in your groups. But even if I change it and make it go backwards and forwards, there's something that's the same for A as for B. So try to figure that out, and then we'll discuss it as a class. That is all.